One moment, I promise I'll be with you.
There's like the answers on the, I'm not how I get it, it's not like you want like a react like sort of form, like when I'm feel like they're like stuck on one and you just don't do it because it's like maybe giving them on the game and they're out there, like that. How do we get through that?
Good question. One moment, let me take care of this and then I'll be with you. Okay, so I'm sorry. Okay, so on my math lab, was formatting an issue? Like you're typing in right answers and it just wasn't accepting it? Did that happen at all?
Yeah.
It's gonna happen from time to time. It's just as you learn to get comfortable with the interface, it's gonna be a learning curve. Now, so just do the best you can. Remember, all you need is 90% to get full credit. So that doesn't mean do 90% of the problems and then stop. It means if one is just giving you a hard time with formatting or you just don't know how to do a problem, keep on going and don't worry about the one that's taking all that time. Yes.
You can redo it many times.
You can do it. We do
Like
it.
either redo, like I'm just alone, but I either I do like redo it, like that, you gotta do it. You have to
I
do
think-
it 90 to be able to redo it.
No, you should be able to redo any problem.
I mean, like, even you can try again, one of the, it's gonna work out.
If you get a problem, right, like say, like if I'm like 7 times 3 and I say 22, but then like finally I say 21, like so that's counted being correct.
Yeah, you're not marked off on the previous one. Yeah.
So like I would be like 100%.
It'd be 100%. But that is dangerous, of course. Don't just like guess random things until you get the right answer. And make sure you know how to do it. Yeah, good question.
Just like you're not getting things up or getting it wrong.
Right. Right. It's understand that it's a growth process. Yes.
The data on that, it's for me.
I try to put up the day of lecture or the next day. So it doesn't go on the hub, it goes on YouTube. And there'll be a link to it on the hub, so you can click and review anything. Any other questions? Who was able to finish the homework in under an hour? Under an hour? Cool. Under half an hour? I think mostly when it takes longer than an hour. Like, oh my gosh, I'm still working on the homework. I think that's when that timer that you weren't actually using kicks in. Sometimes the homework will take longer than an hour. Usually it'll take between 30 minutes and an hour. If it's taking you more than an hour and a half regularly, please let me know what's going on because I don't want to have to spend that long on homework. So talk to me and let's see what we can do about that. But it seems like most of you are able to finish in under an hour, so that's good. I hope it was not too tedious, but with that computer entry, it gets a little bit tedious. But students say they prefer it to do it from the book. So we're going to keep doing that, at least for the time being. So today, day 2, shall we begin? When's our quiz? So it's after the third, day 3, right? I think it's up on the hub. Yes, Karen? Is it 5th, September 5th? That sounds right. Thank you. So next Thursday. Okay. A week from today, so I look forward to. Mackenzie's like, yeah, look forward to it. Yay. Elisa's puffing her fist. Let's take it now. Sorry, you have to wait. We have to wait. I may have just kind of interpreted it wrong. I don't know. Yes, it is. Great question. Quizzes are generally between 20 to 30 minutes and you have to end the class. And in order to for a student to have the time to be able to do it, it's there's time at it. Like if it's a 30-minute quiz, that means like you do the last 45 minutes to do the quiz, and then since we take the habits in time, we'll be able to use that in class. Which means you'll be able to leave early if you don't have extended. Yes, but not for quizzes. That seems like that would be an evil thing to do. Yeah, so quiz material, I'll never teach you something and then quiz you on it that day. Yeah. I might ask you questions, but it wouldn't be for points. Lincoln?
It will be like,
Yeah, the fact that this is an advanced altitude class, yeah, it's not new information. I like how you rephrase it. It's kind of, you're using this tool and this tool to make something new that you haven't seen before. For some people, after the test, you may say something like, we haven't done that. Well, yeah, we haven't done that problem, but we've done all the components of that problem to get you through that problem. And that's a minority of the test, but that's what makes the difference between an A and a B on the test. Like, can you use those tools in a novel way? I'd say an A and a B plus. You can still do really well. If you have a hard time, you can do a good section. On the quiz, it's fewer than 8,000. I don't know exactly that.
but it's like, as most people, it's gonna be able to finish it.
There are times so that if I give you 30 minutes, it's the appropriate number for that. And thank you for asking. There are some questions I just don't give you a good answer, and I'm gonna tell you right now, I'm gonna annoy you with my answer. So if you ask me how many questions are on the test or quiz, I promise I'm gonna annoy you with my answer. It'll be something obnoxious like 7,982, which is unlikely to be that number on the test or quiz. But from my point of view, the question shouldn't be how many questions are on the quiz, but how many are on the test. It should be what's on. And then I'll refer you to the assignment sheet. It's on page 1, 3, E1. And then of course this test. Same. This. Let us get into these. So let's see, we're doing exponents. Yes, I've understood. Testing is 50 minutes. Well, if the test is 50 minutes, that means extended time people have, or it means with extended time have 75 minutes. It's a 75-minute class. So we're going to start the test right at the beginning of class, and if you only have 50 minutes, and you go ahead and do something else the last 25 minutes. Good question. I like that. Would you please hold up the new exponent after we simplify this? Hold up the new exponent, the number of digits. That would be appropriate. Okay, thank you. So it looks like you're not saying x to the 12th. You know it's x to the 7th, right? Okay. Yeah. You guys okay back there? Cool. And this one, please show me what it's going to be x to the 4th. Cool. That's one thing I like about math classes. Everyone can answer at the same time and not be crazy. And if that would happen in history class, imagine the chaos I would ensue. If they all answer with just digits. By the way, if the answer is a negative number, like -1, my recommendation is like this -1, -2, -3, holding it down, instead of the -1, -2, -3. And either way, because I am going to be asking for a lot of answers that way. Okay, so this brings us to some rules of exponents. The product rule says that a to the m times a to the n is equal to a to the. Just check with your neighbor to see if they can finish that out. And plus n, right? That's what we did up here. We're just adding those exponents. As long as the what are the same? What is part of the power column? As long as the bases are the same, you could just add those exponents together. Quotient rule says if we have a to the m over a to the n, that's equal to a to the m minus n For A, it's what to the what. Can you show me with your two hands? Yeah, I'm looking forward to the fifth. Some people would say four to the fifth. You see how they're a little bit misguided. Or just how many twos are being multiplied. It's two to the fifth power. Now, this very first question begs the discussion. Should I finish the problem? Right, doesn't that kind of say, wouldn't that be a pretty good question to ask yourself and like before a test? Am I done with the problem? Should I continue? It's a little bit ambiguous here because let's see what it says, right? Each expression in the simplest form so that all exponents are positive, assume all variables are not zero. Okay, I feel like I've followed the instruction. My exponents are positive. What's that? Yeah. Yeah, it would be strange to keep going. But there will be times they need to do two to the fifth power. I want you to think for a moment, what is to the fifth power? Think about it, don't call it out. And see if you land on the same thing that your neighbor did quietly. I count three, let's hear it. 1, 2, 3. 32. So is it reasonable for me to ask what two to the fifth power is, like on the test? How about 7 to the fifth? Would that be a reasonable question to ask?
No.
That'd be a super annoying question, wouldn't it? If I had you come up with that, like come up with that number, 7 to the fifth power. But 2 to the fifth, I think is very reasonable. Let's keep going to the sixth. What's that? And for these, I actually count on my finger. 6 and 64. Then the next one is 128. Or 128. So 2 to the seventh is 128. 256. 512. 1024. Where do you recognize these numbers from? 512, 256. Where do you see these? Computers? Nothing related to computers? Like memory sticks or something? No. Like a thumb drive? Like gigabyte? Yeah. Okay, for B. This is, of course, 3 to the seventh. Would it be appropriate for me to ask you to actually figure out what that is? I would expect you to be able to do this without a calculator, but I think it would be unreasonable for me to ask you just off the cuff. Oh, what's 3 to the seventh? So I'm gonna leave it like that. This one, do I have to use distributive property for C? Are you sure? Why not? Because there's no addition, right? Distributive property is only over addition or subtraction. So this is just multiplication. And we could use commutative property to kind of move things around and associative property to put things together that are nice. Like I'm just going to multiply the 6 by the 5. What property says I could do that? The associative property. It's a little bit of commutative, like, okay, I moved these around, but maybe the property is just, you know how to do it. And I'm not going to ask you to label that property, but it is 30, x to the 6, y to the 10th. And what do I do with the x to the 6 and y to the 10th? We leave them alone because we're done. Please make sure to stop when you get to the right answer. That's a pro tip for me here. Yeah. Yeah. Mind blown. I'll let you finish these. I feel like you're already on the with the program.
Leave that there.
Yeah, we did.
Or, no. Yeah, that's what I learned. You have to do the exponents first, right? I was wondering, but I'm like, you do the Excel first. I just don't know.
No, because head dogs, you.
And check with the neighbor if you haven't already.
Oh, Brandon. 127.
Each over those.
It's like two.
Negative
-120. Yeah, I wrote the negative.
Yeah.
Where'd you go? We're stuck on, or we're not, we're trying to. We're getting there. -128, and then that would be 16. Yeah. I didn't feel like it was that. Stop. Hold on. Yeah, just 16, 32, 64. Yeah.
Are we about done?
Oh, no. We're debating.
Let's go up to G. I'll give you another 20 seconds.
What's 12? Can you tell me when you get that answer?
Every single day.
Thanks. Yeah. You have to.
Oh, 16 times 132 is.
16 times.
No,
16 times 32.
16 times 132.
Wait, yeah, that's wrong. How did?
Okay, folks.
It's like -4.
I'm gonna guess -7. My prediction.
Let's bring it together. And finished or not, let's just go over these. T is basically the same thing as C, so I'm just not gonna say much. It's just 40x to the 5th and y to the 10th. For E, should I figure out what -2 to the 7th is? It seems like a reasonable request to know what -2 to the 7th is. Should I do that?
No.
Why not?
You just can't do that.
Oh, really?
No.
So I could just rewrite this more simply? Is this true?
It's -2/3.
Is this true that this is just equal to -2 to the 3rd? Do you think this may be what I was looking for? Yeah, if the bases on top and on the bottom are the same, then make sure to consolidate a little bit. So, and we know that -2 to the 3rd is -8. Wasn't that nice? I know you could have done 2 to the 7th and 2 to the 4th, but that's what I'm looking for. This one on top of this fraction, we're left with 6. 6 to the 9.
Out of the second.
Y squared. I guess I don't need a fraction bar, do I? Because if I see, it is true that it's over 1, but let's not force it. So if it's over 1, just leave the over 1 out. That's what I'm looking for. Next. Okay, what do we have? 9x to the y. Questions? B to the 3rd over B to the 3rd is B to the
First.
0, right? 3 minus 3 is 0, which we know is 1. Okay, B to the 3rd over B to the 5th is B to the
1 over oh, negative.
-2nd, which I think makes more sense to go directly to whatever b squared, right? From here to here, maybe. There's more b's on the bottom, so we cancel everything out. You know, 2 b's on the bottom. So this is alluding to 2 different properties. We know that a to the 0 is equal to 1, except in one case, a cannot be equal to 0. Negative exponent rule. A to the -m is equal to 1 over a to the m. Does it feel good seeing some of this after a year of geometry?
Yeah.
Well,
It's like home.
no, geometry was proofs are so easy.
Okay, let's take a vote right here. Let's think about proofs overall. On a scale of this to this, and it could be anywhere in between. I want to know what's your thoughts about proofs in general? Oh, 2 thumbs up. Okay.
Once you get them down, it's so easy.
No, I don't. That's why am I doing?
No, but it's so much easier than like having to do like just circle stuff. So like the random like numbers.
Oh, that kind of stuff.
Yeah, that I
No.
Do you like the tape, by the way?
It's an integral, so it's.
It's half. Yeah. No.
You never leave, so you always have right here, at least. Charlotte, I saw that. I'm sorry, I won't be doing proofs in this class. Not during class. Maybe I'll bring some just for. Good question. In general, don't like negativity. So take no negativity. If you can, avoid the negative exponents. Unless you're using what kind of notation? Scientific notation. Did you do scientific notation at some point?
Yes, but I don't remember.
I remember the names.
Oh, okay. So it's okay. Go ahead and do the first line. Check with your neighbor once you've done all four. Check with your neighbor when we're done with the first line. Make sure they didn't get anything wrong. Because there's at least one that's pretty tricky. You see it?
Sorry. I don't. Wait, which year? Would you be one?
Just the first line.
Just the first line.
Oh, yeah.
Okay, please show me your answer for A.
Oh, yeah. What?
Show me your answer for A. Yes, it is one. How about for B? Take a look around, make sure all your answers are matching. There seems to be some controversy here. It's either one or negative one. It's gotta be one of those. Who'd like to argue for which one it is? And maybe?
There's no parentheses around the negative numbers, so the negative states.
Yeah, we have to think, what is the base of that zero? The base of the zero is?
It scared me so bad.
6. Nicely said, Amy. For instance, if I were to ask something like this, 2 to the 5th minus 3 to the 0. That 0 doesn't apply to the negative, does it? In the same way, it doesn't apply to this. That's why the answer is for sure -1. Do you think that might be something I might throw in on a quiz to see if you're paying attention?
Yes.
On a test, maybe? It's highly likely you'll see that throughout the year, in fact. So make a mental note now. Remember how to do it, and then just be happy with your perfect grade. Who's going to be getting a perfect grade on at least one of the tests in this class?
Let's just be, positive.
Okay, 95% or more. You're going to be getting 95% or more.
Last year, I got like 4.
I don't want to talk.
I want to see a couple perfects. I want to see a couple perfects.
You give like half credits.
Yeah. Oh, not half credit. Yeah, those partial. Partial.
Like if you like mess up, like say it's 4 points, you mess up with a like calculation error, you could get like.
Yeah, calculation, small deductions. Yeah, arithmetic, small deductions. See, this is of course 1/81, and this one is
-1/32.
Should I leave it like this? Maybe 2 to the 5th? Is it clear what it wants? Right, each expression's simplest form, all exponents are positive. I feel like the instructions are ambiguous here. But I am going to simplify it at least a little bit, gentlemen. To say, is the bottom going to be negative or is it going to be positive?
Negative.
It'd be negative. We know that because the 5 is
Wouldn't you,
odd. Yeah, at least.
sorry, wouldn't you make like the whole fraction negative instead of just making the bottom negative?
Yes, thank you. Yeah, one of my things I emphasize is no negatives in the denominator. So a positive divided by a negative is a negative number. So negative, oh gosh. I was looking for a -1/2 to the 5th. And I'd say here I would accept either that or -1 over, what is 2 to the 5th?
4, 4, 8, 16, 32, 16.
32?
Yeah.
2, 4, 8, 16, 32.
Also, if you go back to the last page, we did 2 to the 4th, and it's 16.
Okay, try E, F, and G.
Yeah, they're 2 each.
Oh, try the middle line.
Good job.
Shake it out.
That is so sad. I'm so sorry.
Okay, so it seems like there's some discussion, so maybe you finished. Would like to explain how to do that first of the e's. Would you say it's easy? Ben,
It's just 36
how do you get that?
because it's a negative exponent, so you flip it to the top and then it's just 6.
Are you comfortable with that, with the negative exponent at the bottom coming up to the top as long as it's a factor?
Yes.
Okay, so 6 squared, and you know that 6 squared is 36?
Yeah.
Is that a reasonable expectation to meet for you?
Yeah.
I think so.
Upset.
Okay,
Yeah, use it.
7 squared, no.
Oh.
I think you mean no 6 cubed.
Yeah, no 6 cubed,
Okay,
yeah.
yeah, I agree with you there. Okay, F. What's gonna be on the top of this fraction? 7 is gonna be at the top?
Yeah.
Are we sure about that?
Yes.
Good. Wow, y'all paid attention 5 years ago. And what else is at the top? Y squared. How about the lonely x's? X to the 5th. Yay. Okay, here. What's on the top of this fraction? B to the 4th and C to the 5th. And then the 5. So say 5 to the 1st.
Oh.
It's unnecessary. Anything else on the bottom? A cubed. I feel like this is too easy for you.
No.
No, this is perfect. This is way, way,
This should be.
right where my
entire
life is.
year.
The comfortable place where you already know everything.
Yes.
If we go any beyond them, like,
Okay, try the last line. Of course, there is one pretty tricky one. I can't wait to see a correct answer for I.
I feel like
I want to see it. Once you maybe you want to skip right to I. Because are these two easy for you?
Is it?
Don't call anything out. Don't call anything out. I want to see. Maybe.
I like-
Maybe. I don't know.
I think I checked.
Okay. Let's see how you got this.
Yeah, I think before you go.
Interesting.
Oh, no, yeah. that's- Yeah, I got that.
Can I show you?
Yeah, absolutely.
I didn't do 10 months.
I don't know.
Oh, I see what you're doing. I guess.
Oh, I don't
I get this right.
I can't tell you. I need to stop. I lost all my notes.
It's a lot of math.
Can you switch?
Oh, yeah.
That's what I'm, because I know it's as if. What did you get? Sorry. I don't know if you can move it, there's a plus, so I just like pulled the 6 down and then distributed it. So it's gonna be, I don't know. So you could be right with your. Like that, like, I don't even know.
but two part of it, I understand.
And then I know, and then put it on the ball.
It's 2 times.
These ones and put this into this.
Oh.
But I.
I don't know what the right answer is.
Yeah, I have no idea. You could be right. I
No,
know.
I think.
No, it's. I don't think so.
Okay.
I just don't know.
Did anyone do the second E and H?
Yeah.
So this one on the top of the fraction, we're left with -7, y to the, and on the bottom is.
X.
Is that okay?
Yeah.
Is it okay to leave negatives on the top of a fraction?
Make it one.
It's okay. It's okay. I won't take off for that. I will take off if there's a negative in the bottom. Fair warning right now. If you leave that negative in the denominator, I will take off as little as I can take off at one point. But I think this is nice.
Point. Yeah.
If it's out of 5 points, yeah. If it's out of 20 points, it's not that much. It's rarely out of 20 points. So this one on top of the fraction we have what is that, 5 and y to the 6, and the bottom is x to the 4th. Okay, this one.
guys.
What's the danger in this one?
The numerator.
Everything.
Oh,
The numerator and the denominator. What is the danger here? There's something that makes it dangerous. The plus sign. That plus sign prevents some things from happening, doesn't it? Prevents some motion. Because you can only move exponents around when they're factors.
still don't think I'm right, because
So what I'm gonna do is I'm going to not worry about that stuff. What could I do with that 3 to negative second power?
Can you?
I can write it as, I write it as 9?
1 over 9.
1 over 9.
Oh, we should be playing this one.
Into negative first? 1/2, isn't it? Now, I want to do something with this 3 to the negative first too. What can I do with that 3 to the negative first? I can make it 1/3. Or I can make the top 2/3. Would that make sense? Just 2/3 on top like that?
Wait, why?
Well, because 2 times 1/3. 3 to negative first by definition is 1/3. So I kind of did this. I followed Charlotte's lead and then I made it 2/3. And am I done with the problem? No. Well, I'll let you finish.
About that.
You could do it. You finished?
I don't know, like that's. That's 18, 9 over 18. If I not, I put it up 90.
Yeah, I'm gonna let tell me yes, yeah, it is.
Wait a second. Oh, wait, no, yeah. I'm sorry, not wait, no. That's 18.
Okay,
I think
10 over 18, 10 over 18. So then
At least you're.
11.
Wait, how would you add 1 9
That's
to that?
No, I don't know. How would you possibly do that? Oh, yes.
That's hard. Oh, yeah, I mean, yeah.
Oh,
It's been a while.
18 over 11.
You should like write this out. Like, kind of how to actually solve this.
Oh,
No?
no.
Oh.
Why?
Sam's gonna have to tell you.
Oh.
I think I got it.
I'll go over it though.
Okay.
I will go.
10 over 11.
I think I got it. Can I show you?
Mine as well.
Okay.
Actually, no, I'm not. Oh, wait. You're wait. Oh, wait.
Now, for the next step, I'm not sure there's something you haven't seen here. It's just a little bit different from what you've seen. What would be a good next step here?
Common denominator.
Yeah, to take that bottom and say, I don't want to have 1/9 plus 1/2. I'm gonna take that 1/9 1/2, do a little side work and get a common denominator, multiplying by 2 over 2, is that right? And 9 over 9, something like that. So
It's 2 over 18.
2 over, is it 11 over 18 ultimately? Is that right? Does that work out to be 11 over 18?
Yeah.
Did I do that right? Okay. And how do I do this?
So you multiply 2/3 by, you do it by, multiply by 6, so you get,
Multiply by 6.
or, how do you do it? Reciprocal of 18.
Yeah.
You do it by 18 11.
Oh, well, you don't have to make them the same, because you're dividing.
Oh, you're I see, you're getting common denominator. You could.
So, but you could just do 2 over 3, times 18 over 11, and then simplify the 3 and the 18 to 1 and 6, and then 12 over.
Thank you.
I got
Is that comfortable?
Yeah.
I
got it.
It'd been interesting if we continued by getting common denominator. I think you were saying multiply top and bottom by 6 here.
You get to 12 over 18, and then 12 over 18 times 18 over 11, it's just, you cross out the 18 or split over.
Oh, that is nice. That's also nice, isn't it? That's a good way to do it. Thank you. Which one's better? Whichever way, the right way. Right, as long as you don't move this up. Which I think is a temptation. I think a lot of people did that at the beginning. Just remember when it's part of a sum or a difference, you can't. It's got to be a factor to move them around like that. One thing you could have done maybe is move this down here. Move that 3 down to the bottom, but understand it's still going to be a factor on the bottom. I think we did a nice, sane way. Any questions? Yeah, okay. Now I'm gonna see. Let's just do these two.
Yeah.
And then the other one.
That's true. Like, you're right. Well, eight over expected by years.
Okay, so number 5 is equal to 16x to the 4th. 6 is equal to 8 over x cubed. Is that comfortable?
So whatever you do to the top, if it's an exponent, it applies to everywhere, the bottom, top and bottom.
Yes. Yes. Thank you. So I'm going to formalize this a little bit and say if we have a times b to the m, is it equal to a to the m times b to the m. Yay. Wait, powers to powers. I think I did this right. Powers. Oh, yeah, I definitely did this wrong. I'm sorry. This should be over here.
Oh,
My bad, right? Products to powers. I messed up your notes. Mason, and I ruined your whole notes.
it's already me.
Okay.
White out?
Should we know what the, each of the properties, like, are named, like the rules are named, the power rule, or?
It's good to know them, but I'm not going to test you. What is this? How do you call this? Or
We would
when I'm
know.
speaking.
You're gonna need to know, like, the distributive property, for example, like, so you know how to do it, but not the name.
Distributed property, I do expect you to know that.
Oh.
But that's one of the few properties. Like, I'm not going to say which one's associative, which one's commutative. I'm not going to say that. Unless it's informal. So when it says powers to powers, I hope that it makes sense. This is what we're talking about. And a to the m to the n is equal to a to the m times n. Quotients to powers, now we have a over b to the m is equal to a to the m over b to the m. Which I think you were able to do because you did 5 and 6. So let us try these problems. I'm going to tell you right now, I'm not going to give you a break today because we're just about done. And you're going to have time in class after you finish this to work on your assignment. You finished all 9 of these? Just cheerleading. Just leading cheers.
Yeah. I'm sure. So.
Up top is better, or just on this.
Like in the.
Yeah, like that.
Also, for this one, you should help you go since you want to.
Get used to it. It's always fine. But this is a problem.
Exactly. Please, no, tell me something again.
3 to the 5th? Sure.
Oh, but like,
Hey, you can,
okay, I'm gonna do that.
since you're a lefty.
Thank you.
So-
Thank you so much.
Everyone switches to left hand.
Yeah, you guys can do this, okay? What's?
Yeah.
Check with your neighbor after you finish each row, just make sure everything is correct.
Or I guess 64.
Like, because, no, but like, does it go 64 on the bottom?
No,
Like,
it's
driving the street. That's right.
Oh, okay, okay.
We take a break before, like, starting our homework if we wanted to.
Well, what does a break mean?
Just like walk outside for a second.
And you walk outside during a break?
Sorry, no, like, just like, I don't know.
You can zone out, stretch.
I don't think we'll either.
I'm just gonna put the answers up and I want you to just check yourself when you're ready. I think these are gonna be right.
Certainly. Oh, yeah, it's called.
Make sure mine are correct too.
No.
Wait, why isn't the first one meant?
Did you get to E already?
Yeah.
Yeah.
What's your preferred method for E? Just flip that insides.
Maybe like.
Okay, that's my recommendation. If you have a fraction to a negative exponent, just flip the fraction and proceed.
What if there was some negative exponents like inside?
You
And then.
It's kind of a mess. A mess of negative exponents.
Switch it, make it.
Yeah. Yeah.
Probably.
Wait, no,
And
no.
then
So,
flip
Do
it
you,
again.
is this?
Either that or you could put that negative into it.
When you like.
immediately?
Down,
Yeah,
now
that
you
is
bring
crazy.
this one down to the bottom, is that addition?
Flip it, make it negative
Multiplication.
and then flip it back.
Yeah.
So you would just
Oh,
keep it.
okay.
Like, keep it, make it, because it was negative, it'd be like -7 times -12 is just 14 in the denominator.
You're talking about,
I'm pretty sure you just.
He's here.
I see. I'll go over that.
It's really yes, so for something like from this problem, actually.
Oh, I think I'll go over the bottom three together because there are a lot of
Oh.
intricacies.
But it's like so when you have like, so say you gotta bring it down, say 3x, the negative second you bring it down, you multiply, you don't add it to the denominator, you know, like.
It's not multiplication.
You multiply.
It is?
Yeah.
Wait, so then how did we get?
Are we good up to F?
Yeah.
Did I get it right? Everything's right? Okay, I think they're getting a little bit tricky, so I'm gonna stop being so fast about it. I think I'll clean this up just a little bit by bringing the y's up. What do you think? Would that be wise?
Yeah.
Yeah.
So sorry about that. Okay, so we're left with y to the 9th here. We're left with negative 3x cubed. I think I'll take that negative out because I don't want that negativity in the denominator. I have to deal with that negative second on the top, so I'll bring it down. 3x squared, is that reasonable?
Yeah.
And now let's kind of bring it all together. So we have negative y to the 9th over the bottom, which is, how many threes do we have down there? Ultimately, we have, yeah, 3 times 3 times 3. We have a 27 down there. And then x to the 5th. Is that what you already had?
Wait, how do you get the
Wait,
27?
maybe, yeah.
It's 3 squared times 3 from several.
Oh, 3 squared is 9, not. Not-
This
not
only
6.
applies to the
I'm sorry.
x. So you have 3 times 3 times 3, 27.
Wouldn't it be?
Can I miss something?
Would it be x?
Well, this is x squared.
Yeah.
This is x cubed, x squared times x to the 6th to the third. We have to use the first one. We have to use the fact that a to the m times a to the n is equal to a to the m plus n. It's a product of powers, adding the exponents. And thank you for asking. These little things are confusing. If you wrote a 6 here, just make that mental note. Why is it not a 6? Why is it not a 6? Make sure it's understandable to you and not just like,
Oh, which one?
oh, I'm 1 away. It's close enough.
Which one?
Like over here, you said it's a 6, and it's easy to see when someone would say it's x to the 6th, but it's x squared times x cubed. You're just adding them together. If you're ever unclear, do more than you need to. What I mean by that is this bottom becomes 3x times 3x times 3 times x times x times x. just expand some of those. So maybe here it's easy to see, oh, there's the 27 and it's just x to the fifth power. But if you're confused about the rules, expand it and just count ultimately. Or maybe make a simpler problem. Okay. Should I move on to H? I see just a little bit of negative exponent issue, so I'm gonna move the that negative x to negative 9 up, and everything else is gonna stay the same. Negative x to the fourth, negative x to the eighth, negative x to the ninth over negative x to the seventh. So this is really testing now to see if you understand how to deal with that negative issue.
No.
Any recommendations what I should do here?
Top row first, I would say.
Let's work on the top. Haley, you're raising your hand?
Yeah,
Okay, yes.
the negative x, just put the negative.
So put this negative to the side, like that. Okay. Yeah, Elise?
Negative x to the fourth would end up being positive, right? Because if you multiply negative x and negative x, then the negatives would cancel out, so that's.
So we
one.
could just do this, basically?
Yeah.
Do we agree with that?
Yeah.
Okay.
And then negative x to the ninth power would stay negative, so you would have negative x to the ninth and negative x to the eighth,
Okay.
which would end up being positive.
Wait, does this stay negative?
Yeah.
The middle one, does it stay negative?
Oh,
What do you think? It stays negative, yes or no?
wait, no,
It's already
it's in there, yeah, it does.
Yeah.
Does it?
Yeah.
Yeah, it says negative.
Stays negative because
It's already in the.
The actual-
it's already in the front. This
Yeah.
H belongs to only the X. It's saying negative X times X times X times X. X. So that negative stays there. So we have negative here, negative here. The answer will be negative ultimately. So I'm going to cross these out. So this is all analysis of what we have here. And on top, maybe I'll cancel this from here, delete two of these so I could, so a little bit easier. 12, 13, 14, is that right? Negative x to the 14th.
If you don't. It isn't, so the negative, so the middle one, we said that, where it's actually the 3 in the middle. Right, that one, we talked about,
Three
the middle one on the top, numerator,
for H.
yeah.
And so 3.
Oh, the 8, sorry.
Okay.
Why'd you make that positive if it stays negative?
Oh, what I did was I said this is negative and this is negative, and negative times a negative.
All right.
It's a positive. I'm just cleaning up the negative stuff.
Yeah.
Thank you. That's a good question. Lastly, do I want to flip that fraction?
No.
I could.
You could just like simplify it first.
Yeah, let's simplify the inside the fraction first. Is that what you mean?
Yeah.
Right. I see that negative 6. I see that negative 2. I know it's going to cancel. Negative 3. What's going to happen with the x's?
No. The
Top or
x-
bottom? Where are they going to land?
Oh, and the top,
Oh,
actually the third on the top,
Well,
yeah.
yeah.
X cubed on top, isn't it? So on the bottom is,
2 at least.
well, it's 1, I think now, isn't it? Did I do that right?
One.
Yeah.
Yeah, I already got rid of that 2 with the 6. And normally I don't like ones in the denominators, but I keep in mind that I'm going to be taking this fraction and flipping it. So this is 1 over negative 3x cubed squared, which is equal to 1 over 9x to the, is it 6?
Yeah.
This time is 6?
Yeah,
Why is it 6 the time?
because the next one is outside.
It's outside. It's a power of a power. And I'm multiplying two different powers together. We like?
Yeah.
You fans of exponents?
Yeah.
If you aren't, you should be. You're about to have some practice with it. So you have 25 minutes. Work on that assignment of yours.
If you get 90% done.
You might be able to get all of it done. Who knows?
Yeah.